Welcome to Richer Scale Modelling. I've been asked to explain a little bit more about how I light up my models and how I go about it and what I do. Try and make it more basic. But first of all, to do that, we've got to have a small basic level understanding about the different components that I use. So I'll just go through these. So first of all, we have these. Now these are light diodes, LEDs, and they come in two basic sizes. We have a 3mm and a 5mm, like so. There is also a micro light as well. You can see that little yellowy orange thing in there. That's an LED light, and that's the way. Now I hardly ever use these because they are a nightmare for me anyway to wire up. So I tend to stay away from them. But you can buy them pre-wired if you wish. And you can see the advantages straight away. If I put it up to a 3mm diode, the size difference is immense. And these are just as bright as your diode, but take up a lot less room. But they're more difficult to work with what I find. So I won't actually be talking about these because I hardly ever use them. The next set of common lights that you'll see me use are these. Now this is an LED strip, and they generally come in 5m like this, and I can just unwind it. When you get them, they'll come in two types. They'll come in weatherproof or normal. And how can you tell the difference? Well, simply, the weatherproof one, which is this one, or the film over it, or the plastic covering on it. If you use these on your models, which I do sometimes, you have to take this plastic film off. And I generally just cut a line down there very carefully and peel it back. But it is a pain to do. The other one is the normal or non-waterproof, and that's these. So again, they come in a 5m run, and they come like this. So these are the three main lights I use. So let's have a little talk about them. The LED strips are very versatile and very good to use. They come with their own little sticky back. Now you just remove this bit of tape if I can get it off, depending on how long they've been sitting for, and that's sticky. Now each section of light runs in three, so 1, 2, 3, and if you see this funny metallic thing here that I'm pointing at, that is the contact point. So every 3 you're going to have a contact point. Now what this enables you to do is you can then cut them to the size in multiples of 3. So if I only wanted to light up a small space like that, I would cut this here. So all I would do, once I find my scissors, is take my scissors, get about the halfway point and cut. Then I would end up with that. On each section that is marked, get my fingers all the way, is marked positive and negative. There's a little plus sign and a minus sign on each side of the tape. Don't think the camera can quite pick it up. There you go. So you see the minus and positive. The 12V indicates it's 12 volts, and that's the maximum power that you'll need to light these up. Don't go over 12 volts because you'll find that you'll blow the lights. Now, in order to connect these, you're going to need some wire. I've got a black piece of wire and a red piece of wire. I always use the red for the positive and the black for the negative one. It just makes it easier. You can use any colour of wire, but try and use the same colour that you do everything. That way you won't get mixed up. You will also need a solder iron. which is here. I've got this one. This is just it's a cheap generic one, and it's got a little dial to control the temperatures. As you see, it's dusty as hell. And going to be needing some flux, and of course the solder itself. Now the solder is a rosin core and lead free. Rosin core is probably the better one for electronics. And there is another one out there. I can't remember the name of it, but don't concern yourself with that. This is the sort of thing that you're after. These are the content of, oh, it doesn't tell you on this one. But yeah, the rosin core solder. So now that I've got the components to light this little strip up, I have to prepare it. So first of all, we've got to bare the wire. Now, how I do this is the wrong way to do it, I would imagine. Well, it is, but I just do it this way. Be careful, because you can cut your fingers. I have my hobby knife, and I put my knife on the plastic sheath and gently rub it over until I can feel it bite into the wire. Doesn't take a lot, just a little bit. Then I'll just twist it around, roll it in my fingers, and do it. Now, the reason why I'm not cutting my fingers is, one, I'm doing it very slowly, and two, I'm not digging into it, so the blade is not going over my skin. And once that's there, I just then simply pull the sheath, give a little twist, and then I bare the wire. So I've turned on my solder, and now I'm going to do a process called tinning. So I've just got this little clamp tool here, and I'm going to place my wire in here. I've got two clamps here, so I may as well put both in. And all I'm going to do is run a bit of solder along the wire. So I'll get my solder iron. Now, I can't touch it, so I'll just turn it on. The thing about solder irons is the tip here wears out. Now, this one is almost gone, but not quite. When you buy a solder iron, make sure that you can get the tips for it. Some of the really cheap generic ones, you may not get a tip that will fit it. So just bear that in mind. So now I'm just going to, yeah, the tip's almost gone on this. You should see a little bit of smoke. Here we go. And I'm just putting a bit of solder along the wire. Doesn't need much. Now, if you've got too much solder on there, it will drop off like it did there. And I'll just do the other side while I've got this out. So that's both ends done. Just takes seconds really, and that's ready to go. The next part is the tape. Now it's the same process, just slightly different. Now I'm taking a little bit of tape and I'm just holding it down. It just makes it easier to solder up. But this one's slightly different because I'm going to be using the flux. Now what this does, this stops it from burning the material that you're putting the solder on. Now you can use a matchstick or the cocktail stick, anything really, and just put a little bead of this stuff on the contact point. And the same process again. I'm just putting a bit of solder onto the actual contact. I really must change this tip. So we've got that there. I'll just let that cool for a second. Only takes seconds to cool, but I'll wait until it's slightly cool. You know it's cool because it goes from a shiny colour to a sort of dull colour. And now it's time to place the wires in. So all I'm going to be doing is heating up the solder that I put on. And once that's soft, which it is now, I just simply push in the wire like that. There we go, that's all right now. So I'll do the same the other side. It's taken longer than normal because, as I say, my tape is almost gone, but I don't want to change it just yet. I can get a few more solders out of it. It's probably the Scottish in me. So I'll go and do that one. I should say though, obviously the red is a positive, the black is a negative. So that's done. Just turn it off. So now we can test to see whether this has worked. Sometimes you may get a faulty batch, and also sometimes your solder is not as good as you hoped it would be. Now, to power these up, I use a 12 volt adapter connector for this, and I made this little thing up myself. It's just 2 crocodile clips wired in to fit the connector there, and then that just gets pushed in to the adapter if I can find the adapter. So this is connected to a 12 volt mains adapter. So then it's just ideal for testing lights as you go along. Now you can of course use a battery. This is a 9 volt battery, and again I've got a couple of crocodile clips soldered to a connector. Now I haven't used this one for a long time, so I don't know whether this will work or not. The battery may be dead. Yeah, I think the battery's dead. Put the red to the red, the black to the black, and there we have the light. Yeah. And then what I would do is those joints here, the solder that I just made, I would put a little bit of hot glue over it just to insulate it and protect the joint, because these are quite flimsy and they can only take so much bending before they peels away and break. So it's better to protect these as soon as you can. You can also just put a bit of tape over it, a bit of electrical tape, but I prefer the hot glue. Plus the fact when you put it in your model, your little bit of hot glue then will hold the tape down. And that is the first light, basic light setup that you'll probably use to put in your model. You can secure it by just taking off the tape or a bit of hot glue. Even super glue will work. But then if you want more, you would just link this up to the other lights. They can also be linked up to your diodes, your 3 and 5 millimeter diodes as well, like that, and putting power to it. But that is the basic setup that you would put in to your kit to light a little bit up. The diode is a little bit more complicated. You can purchase these like this in a little kit, or in 5s and 10s and whatever your needs are. Because I do a lot of this, I tend to purchase them in bulk like this. Now the first thing you've got to do is know where your positive and minus is. The larger prong, so you can see the prong sticking out a little bit there. Just hold up to the camera. That is your positive, and that is your negative, the smaller one. So you can take this and just gently prise them apart, getting ready to wire up. Now to wire it up, you're going to need a thing called a resistor. Now a resistor regulates the current going to the LED or the diode, and these funny looking things are resistors. When you buy them, they'll generally come like this. There's many different types and values, which I'll quickly go through. It's important to get the right resistor for your light, because you can blow your light if you don't. So a resistor. Now this is a 3 LED diode. connected to a resistor. Now you can see a different colour there that I just shown you. We have various colours, various sizes, and it can all get very confusing. Now, as I said, you need to know what value your resistor is. And the value is important, as I said, because it directs the current and to your light. Now, these come in tape form like this. Now, if you look at each resistor, the camera can pick it up, there's a little band of colour. There's a little band of colour on each resistor, and these colours are different. And these colours indicate a value that you use simple maths for to find the resistor value. And to make things more complicated, depending on the company you buy the resistor from, these bands can be a 3-banded resistor, 4, 5 or up to 6 bands, but they all denote the value of the resistor. So how do I do that? Well, luckily there is a simple chart to follow for you to do that. Now, the resistor, you read it from your left to your right, and you're able to tell the left and right, because at one end there's generally a metallic coloured band at the end, but we'll get to that in a moment. First of all, the actual chart that you'll need. As I said, each band denotes a different value. So a black would be 0, a brown would be 1, a red a 2, an orange a 3, a yellow a 4, green 5, blue 6, violet 7, grey 8, white 9. Then you have a gold band and a silver band. So the easiest way to do it is, if you look at a chart, and I'll put a chart up for you, this one, I'm going to have to put a magnifying glass on for this. This one is a yellow, a violet and a brown with a gold bar at the end. So I simply look at my chart, and my chart says for the yellow it's 4, for the brown it's 1, is that brown? No, sorry. For the yellow it's 4, for the violet it's 7, for the brown it's 1. So you got 4, 7, 1. At the very end, you have the gold. So how do I work out the value? It's very, very easy. Your first two values, this is a 4 banded resistor. Let's take if it was a 3 first of all. Your first two bands, your 4 and your 7, put them together for 47, and your third band is your multiplier. Now the multiplier is on this one, it's a brown, so that's a 10, and this is 10 ohms, OHMs. That's just the measurement, name of the measurement. Now, so all I would do is I would take the 10 and multiply it the 47. So obviously that's 470. And that's the value, 470. On other ones with lesser values or more greater values, like this one for instance, you have the blue one here, so we'll locate the metallic stripe. The first two values is a 2 and a 1, so that's 21. And then the multiplier is 1, so it's a 21. The fourth band is the tolerance. So each resistor can come with a tolerance. So this tolerance, because it's brown, is a +1. And the last band on this is a temperature. Some of them have that, some of them don't. Don't worry too much about the temperature so much, or the tolerance. Your main concern is the actual main number. And that's the easiest way. It sounds confusing, but it really isn't. It's the first two numbers, so a 2 and a 1, 21. The multiplier is 1 on this one, so it's a 20 ohm or 21 ohm resistor compared to 470. And that's how you do it. Now, so in case I'm not explaining it properly, I've taken this off an open source website that allows you to deal with the resistors and the values of them. So if you have a quick read of this, hopefully this will explain it a little bit better, how you should deal with resistor values. If you're still a bit confused about it, there's lots of stuff online from the manufacturers of these resistors to help you out. The reason why you need to know these as well is because depending on where you buy these from, you can say buy them from China and they may come like this. And that's how my first batch came. No values were written on them. There's meant to be various resistors in here with different values. So if I've been using any of these, I have to calculate them before using them. So it's quite important to know. However, if you buy them from a better company, I'll come in a box like this, and each bag will have the value on it. So this one is the 20 ohm, just like the one I shown you, and it has various values. Here's a 470. There's a 0 ohm. There's a 4.7, 2.2. So various values there. So you don't actually have to go and work them out if you buy a kit like this. That's the resistor kit. But more importantly, on this kit, on the underside, you have your chart. So there's all the different colours I was talking about, and these are all the different values. And then I'll give you an example here how you multiply them. And it's from it goes up to 5 band, this one, and it's just a part list what's inside. So I'm going to take my resistor. I know it's a 470. Now I generally use 470 on these LED diodes. You can go lower or higher, and it will be the brightness mostly will be affected. But if you go too much, you can blow the light. So I find that 470 is probably the happy medium. Not too bright, not too dull, and it won't blow. So in order to connect these, once I know the value of the resistor, I take the resistor with the metal wire and I place it on the positive side. And all I do there, I'll just take the prong and I'll just wrap this around like that. So I've got a good contact there. And then I will solder this in position. So I'll just turn on my solder iron. You can wrap this around as many times as you want. Just be careful. You don't do it too tightly. You don't want to break your resistor. I'll just take my little vise here and just connect it up. And I'll just solder this in. So it's very simple to solder. You've never soldered before, just have a go. Just be careful of the tip. Obviously it's red hot. You don't want to be touching up because you will burn yourself. And just add a little bit of solder once I get this started. There we go, that'll do. So that is all soldered, and then what I like to do, it's not really necessary, I just like to take the tail ends and snip them off so it's nice and neat. And the reason why I do that is mostly because the sheath I'm going to be putting on is not going to get caught on anything. Put the resistor on the positive and the negative is bare. And then I shall take my connector, try it out, and put it on the positive. Always put it below the resistor not above. So don't put your connector there where you're testing it, because obviously the current is not then running into the resistor. You can open these up further if you want, and then I'll just test it, see whether it works. So there it is, there it works, and that is the basic of there, but I'm not quite finished. So now I've got to wire this onto a bit of wire. You don't really have to, it depends where you're placing it, but if you're having it in a model, there's a good chance that you need your cable to go somewhere. So again, I'm just going to strip the wire, and again I'm just going to tin the wires. Get my wires, and all I'm going to do is to connect these, I'm just going to twist it on, so the resistor to the positive, and I'll just make my connection like so, and of course the neutral. So as you can see, I'm just twisting these around, so making sure the bare metal touches the bare metal, and then I shall solder these up. That's them soldered, so it's as simple as that. And again, take away the excess, and I shall test the lights. So neutral on neutral, positive on positive, and then turn it on. So that's that all working fine. Next, I'm going to be covering these up. So I've got the shrink wrap sheath. These are for electrical wires. They come in various sizes. This is quite a small size because it's only like a 1mm wire. And then I'll just push it up into it, up to the diode itself. Same with the other side. Like so. And then I'll just use my clamp once more. Make sure your iron, solder iron, is clean. And then I'm just going to take it and gently run over, and you'll start seeing this, just move over a bit, you start seeing this shrink to the wire. There we go. We should do the same for this side. You of course can use a heat gun to do this as well, but since you've got your solder iron on, you may as well use that. And that's that. Now you can take a bigger sheath like that one, so you see it's a larger opening, and then you can put the two wires together like so. I hardly ever do this, but I'm just showing you that you can do it. This will take a little bit more to shrink down. It just makes everything nice and tidy, if you prefer that way. Personally, once it's in the model, you don't say so, I don't care. But I know a lot of people would like it nice and tidy. And then you end up with that. And then, as always, I do a light test, because I've done something different. We'll just connect it up. There's the light on. And that's it. And then, of course, I would put it in the model. Now, as I said, they can be connected to this. So I would just connect that to that, that to that, and have that as my power source. Run a cable through there, and then the power will go directly to that. Or I can even branch off, put a power cable here and here, and the power will go in to shut off into those two areas. Now, this is how you do it from scratch. However, you can buy pre-wired ones, and this is a pre-wired. You can buy these anywhere off the net. This one I think might be a flashing one, yeah. I tend to buy I used to buy the flashing ones pre-wired. You weren't able just to get the normal diode, flashing diode, and having solder it up yourself. But nowadays you can. But I've still got a few of these left, and as you can see, it's basically like that. You can just about make out the resistor there, and they put a bit of sheath on to protect it, and you would buy it in a bunch like these. When you get a lighting kit, this is what you'll get. You'll get things like this without being pre-soldered, so you would still have to do all the soldering. The diodes you would probably get pre-soldered, pre-wired, like that. And you may get a motherboard, a circuit board I should say, as well, to connect them if you want to control the flashing. But that's a whole different light setup. This is just the basic. So it's entirely up to you. You can buy these and just go straight to it, or you can buy something like this and do it for yourself at a fraction of the cost. This costs like £5-6 at the time. Same with the 5 meter straight, and I bought this about 4 or 5 years ago, and I'm still using them. Same with the light straights. So with that and the resistors, it was about £15 in total. This for this bunch of LEDs, this cost, I think it was £8-10, something like that. Back then. It's probably more now, depending how many you want. They generally come in 5 for about £8-10 nowadays. So for that amount of money, you can actually get all this and do it yourself. It may take a little bit of time until you get used to it, but you can wire one of these up and a diode up within minutes. Once you get used to it, then it's just a matter of where you'd like to place it in your model. So that is my basic guide to how to light up LEDs. If you've got any questions, let me know. I'm by no means an expert on this. This is just what I've learned down the line. The charts and that I'll show you, that I'll take a photograph from the box and put up. You can see all that online. There's an explanation online as well, how the resistor color code works and the multipliers. But I'll put a link in, I think, if I can find a decent site, in the comment section, in the description section, so you can have a look at it for yourselves and say it's done. But I don't actually see the point of paying all that money for light kits and things like that when You can do it yourself. So all I have to say is, why don't you subscribe to the channel? And if you do so, hit the notification bell. That way you'll be kept up to date with all my future builds. Hit that like button. Don't forget to leave a comment, and of course share the video. But for now, thank you all very much for watching. Bye bye.